Welcome to 5.4 Sum and Differences of Cosines. Open your 5.3, 5.6 note packet to page 10 and take out your green sheet. And this video is featuring Miss Weldon,
Mrs. McFadden,
and Miss Paddock.
The objective today is you'll be able to use the sum and differences of cosines to evaluate trig functions, verify identities, and solve trig equations.
Yay!
Okay, so our formulas we're going to use today are the difference identity for cosine and the sum identity for cosine. Okay, they're on page 10 at the top of the page, so you can reference them there.
Here are your Pythagorean triples. These should be written down from yesterday's notes. If not, pause this video and write these down.
Let's move on to example 1. We're going to calculate the cosine of a 75-degree angle. Notice the 75-degree angle is not one of our unit circle angles. So we need a formula that will help us calculate the cosine of a 75. That's where our cosine alpha plus beta formula comes in. Think of two angles that add up to 75 that are from our unit circle. How about let's use 45 plus 30. So 45 plus 30, you could also write 30 plus 45. The order doesn't matter in which you add. And we're going to plug it straight into the formula. The cosine of alpha is cosine of 45, and then the cosine of 30 minus sine 45, sine 30. So this is where our unit circle comes in handy. We look at the cosine of a 45, and the cosine of a 45 is square root of 2 over 2. That would be our x value of a 45. And the cosine of a 30 is the x value of our 30. That would be square root of 3 over 3. We're multiplying, so we use parentheses, square root of 3 over 2. And minus sine of a 45, that's the y value, so we use square root of 2 over 2, times the sine of a 30, which is 1/2. And we know with fractions, we multiply straight across the top, straight across the bottom. So the square root of 2 times the square root of 3 is the square root of 6, not square root of 5. We don't add them. And 2 times 2 is 4, minus square root of 2 times 1 is square root of 2, over 2 times 2, which is 4. We have a common denominator, so a simpler way of writing this would be square root of 6 minus square root of 2 all over 4. And we're done. Voila. Moving on to example 2.
Okay, on this one we're looking for the cosine of 15 degrees. So we're looking for two things that 15 is not on our unit circle, so we want to use two angles on our unit circle that will give us 15 degrees. So we're going to use the cosine of 45 degrees minus 30 degrees. Okay, so if we look on our unit circle, cosine 45 degrees, cosine 30 degrees, plus sine 45 degrees, sine 30 degrees. So from our unit circle, cosine of 45, square root of 2 over 2. Cosine 30 degrees, square root of 3 over 2. Plus the sine of 45 degrees, square root of 2 over 2. Times the sine of 30 degrees, which is 1/2. To simplify this, we're going to multiply straight across. Square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Adding, so plus square root of 2 times 1 is the square root of 2. Over 2 times 2 is 4. Okay, to simplify, we'll make one fraction. Square root of 6 plus the square root of 2 all over 4. So that's it for this problem. Guys, did y'all know that we're up here on a Saturday recording these videos for you, so your teachers really love you.
A Saturday. I'm going to the movies today.
Happy Saturday!
Happy Saturday, everybody.
Moving on to example 3. We're going to find the exact value of cosine alpha plus beta. And notice that we have the equation written for you. So we're finding cosine alpha plus cosine beta. And we're given that alpha lies between 0 and pi over 2, which is in the first quadrant. So we're going to put alpha in the first quadrant, and notice that beta is between 0 and pi over 2 as well, so we're dragging beta into the first quadrant. If you look at your equation, they've given us that cosine of alpha is 4/5 and cosine of beta is 12/13. So we're going to draw alpha in the first quadrant, and we're going to label it. Cosine is 4/5, so that's the adjacent leg, 4, and the hypotenuse 5. And we know that cosine of beta is 12/13, so we're going to draw beta. Cosine is 12/13. Now, notice from our formula that we not only need cosine, but we also need alpha, or sine of alpha and sine of beta. So let's go back and let's find the missing side. So we know that that's a 3, 4, 5 from our Pythagorean triples. And we know that this is a 5, 12, 13 from our Pythagorean triples as well. So now we can find the sine of alpha. The sine of alpha is 3/5, that's opposite over hypotenuse. And we can find the sine of beta. The sine of beta is 5/13. And now we're ready to plug in our formula. So we have cosine alpha, which is 4/5 times cosine beta, which is 12/13, minus sine alpha, which is 3/5 times sine beta, which is 5/13. We know from fractions we multiply straight across the top, straight across the bottom. We get 4 times 12, which is 48, over 5 times 13, which is 65, minus 3 times 5 is 15, over 5 times 13, which is 65. We subtract and we get 33 over 65. Should our fraction reduce, we would always reduce, but this one does not, so it's simplified and we're done. Yay! Moving on.
All right, last but not least, example 4. It says find the exact value of cosine alpha minus beta. Since it tells us in directions to use cosine of alpha minus beta, that's the formula that we're going to be using. Next, it tells us that alpha is between 3 pi over 2 and 2 pi. So alpha is going to be in quadrant 4. Keep in mind, in quadrant 4, cosine is positive and sine is negative. Okay, you have to be really careful on your positive and negatives. Beta is between pi and 3 pi over 2, which is in quadrant 3. And we know in quadrant 3, sine and cosine are both negative. All right, now we need to set up our triangles. They give us cosine alpha is 7 over 25. All right, so the adjacent side is 7, and the hypotenuse is 25. And if we draw in our given, it says sine of beta now is negative 5 over 13. So our opposite side is negative 5, and our hypotenuse is 13. What we need to find is sine alpha. So if we use our Pythagorean triples, our missing length is 24. Make sure you make 24 negative because y is negative in quadrant 4. Next, we have to find cosine beta. The adjacent side is 12. But again, 12 has to be negative because your x value or your adjacent side is negative in quadrant 3. All right, so sine of alpha, based on our triangles, is opposite, so negative 24 over hypotenuse, which is 25. We already have a negative. And what do we need to find? Cosine beta is adjacent over hypotenuse, so our cosine beta is negative 12 over 13. Now plugging in, cosine alpha is 7 over 25. Sorry. Oh, that's okay. Cosine beta is negative 12 over 13. Plus sine alpha is negative 24 over 25. Times sine of beta, which is negative 5 over 13. 7 times negative 12 is negative 84. 25 times 13 is 325. Plus negative 24 times negative 5 is a positive 120 over 325. When we combine that, we have a common denominator of 325, but our numerator will be 36 because negative 84 plus 120 is 36, all over 325. And that doesn't reduce, so that is our final answer.